This is my screencast for my memory management assignment. So we already have the code open, but I'll go ahead and we'll open it up again as well. Okay, so we go up to the top here. So C program, we have my include statements and constants, and then I define the virtual space as 1 MB. So that's 0x000 f, and the physical memory is 512 kilobytes, which is 0x0007 fff. Um, so the program is basically like broken down into several module functions to avoid the redundant code. So our first function we have is our print binary. So basically what this does is it takes any value and it prints it as a 16-bit binary number. And then the one with the least significant bit on the right, and then I mean, this is what the assignment required. So next up we have our print size info. Um, so this one it just displays the page size in decimal, binary, and hexadecimal all at once, so we could see it no matter where we are. And then we have our build page table. This is where I populate the page table array, and then the virtual pages that map within the 512 kilobit physical space to get a valid frame address. Anything beyond that will get marked down, and then so I have that as 0x, and then a lot of Fs, and then I use that as my flag for pages that are currently on the disk. And we also have our the translate address. So in this one, this is the core MMU logic. Like I said, like the MMU works, takes a virtual address, divides it by page size to get the number, and then the remainder is the offset, and then it looks up the frame in the page table, returns either the physical address or it's already on the disk, so it'll output currently on disk. And then lastly, we have our translation loop, which just handles all the user input, and then prompting for the addresses repeatedly until the user, clicks no. So if we want to go ahead and run this, so we can see it in action. So as we see, prompts 495 or 8191. So we'll start with just the 495. 95. And then you can see it immediately displays the page size in binary and hexadecimal. And then the binary output shows all 16 bits with the least significant bit on the right. So we'll enter some uh some mapped addresses. So if we go 0x 01, boom, we can see um the MMU extracted the page number and offset looked it up in the page table and then returned the physical address. So this means, of course, that the page is loaded in physical memory. And then if we do another one, we'll do 0. As we can see, oops, I forgot to click yes. So let me run that again. Sorry about that. I can actually pause this right back to where we were. Click yes, and then we'll do. Or no, we're doing A, right? Boom, as we can see the page number. So this address falls beyond the this one falls beyond the 512 kilobytes we have, so the page is invalid. And then if we want to end that, we could go into our the other one we have going on. So, boom, and then we'll just run 0x. Boom. So this just demonstrates that both of our page sizes work correctly. And then, yeah, that's pretty much it. Thank you.